Okay, hey guys. For this lab, what we're going to do is we're going to look at what happens to a motor during a single phasing condition. We're going to have a motor connected up. We're going to have it with a light load and full load. Single phasing fault happens. What causes a single phasing fault? Well, if we have a look at this motor circuit here, there's a lot of different things that can cause a single phasing condition. The fuses here, if we had a momentary locked rotor condition, the voltage goes up, the current will go up to 6 times the FLA. That current can cause one of these fuses to blow on its own, and then if the load drops off, we could be left with 2 fuses good, one of the fuses not working, and can cause that single phasing condition to exist. Also, we have all these different mechanisms. We have our switches, our contacts, and our overloads. The linkage in these disconnects, one of them could fail, and when you close the disconnect switch, one of the blades may stay open. With our contactors, these contacts over time, because when they open and close they arc a little bit, they eventually can wear out and you can actually burn out one of the contactors. That can cause a single phase condition. The overload heaters, they can actually burn open, or they can overheat and they can actually develop an open. That'll also give us a single phase condition. Plus all these termination points, okay, where we have conductors screwed under terminals. Each one of those, if they develop an open, will again give us a single phase condition. And then also the last one here that can be common is we get an open in one of the windings. That'll give us a single phase condition. Now, in our lab here, we need to simulate a single phase condition. So what we've done is we put a switch in line with our line 3 here. So what's going to happen, we're going to run our motor, we're going to open up line 3, and we're going to see what happens to our motor when we do that. Also, I put an ammeter on line L2 here and a voltmeter across our coil, so we can have a look at the changes in current and voltage. Okay, here we have our motor connected up to our 208 volt supply. It's a parallel Y connected motor here. Okay, and you guys remember all your connections. We have a voltmeter connected across one of the phases of the Y connection, so we can see what our phase voltage is going to be. And then we have our ammeter here in monitoring the current of our line current there. Okay, now we're going to go ahead and start it. So right now our eddy current brake is being used. It's off. So this first reading we're going to take is going to be a low load situation. Also, if we have a look over here, we have our drum switch that we're going to use for our to create our single phase conditions. Right now it's closed. We'll bring it open and it'll disconnect line 3 from our motor, and we'll have that single phase condition occur. Okay, for now, we'll leave it on. And also we'll check out the RPM later on, what's going to happen when it's loaded. Okay, so shall we give her a start? Right now we have 1.9 ounce, which is quite low. The FLA for this motor is 3.4 ounce, full load ounce of this motor. Okay, so now we're going to have a watch of the current here, lightly loaded, and we're going to create that single phasing condition. You can see the current reading okay? Flare? Okay. So let's have a look at our current reading. We're going to have to create our single phase condition now. Okay, our voltage dropped a little. Our current has gone up from about 1.7 up to 2.9. And our RPM is about 1788. Hasn't really changed at all. We put it back to a three-phase condition. And again, not too much change. Okay? So again, now with our single-phase condition again, our current goes up to 2.9 amps. Our RPM is about 1789. Not a lot of drop in speed. Okay. Now we're going to engage our load current. Okay, full load current is 3.7 amps. Okay, now that's at all three phases. Our RPM is about 1697, 1700 RPM. Okay, now I'm going to go back up to the current meters here. Now let's create our single phase condition. As you can tell, the currents jumped all the way up to 17 amps. So it started rising quite high. Okay, now let's go have a look at the same single phasing. We'll make the single phasing, fully loaded single phasing condition occur again, and let's watch the RPM. It's dropping down all the way to stall condition. Okay. Okay guys, we're going to leave it single phasing, no load, and we're going to try and start it up. Okay, here we go. I'm going to start it. Now let's see what the current does too. Okay, motor's not turning at all. It's just sitting here humming. We're up to 17 amps. Okay. Phase voltage here. The voltage went down to about 100 volts. Okay.